This lecture was developed by Danny Kessler, associate professor at Dongso University and Korea's first PhD in wellness tourism. Navigating a crowded city at night creates an immediate state of sensory overload. To cope, our instinct is often to withdraw, physically blocking out the environment with a pair of earbuds. We use music to create a psychological barrier against the world. But listening is a passive experience. While it can shift your mood, it does not engage the body's internal biological recovery mechanisms. We often mistake isolation for rest. However, to actually pull the body out of a heightened stress state, we need a physical intervention that moves beyond silence. In Korea, the 𝗨𝗏𝗡, or private singing room, is a permanent fixture of every neighborhood. While these are categorized as social venues for entertainment, they facilitate a consistent, deliberate application of sound that impacts the human nervous system. Your voice is not just for communication, it is a mechanical tool. Producing sound is an active biological process that initiates measurable changes in your physiology. Singing requires you to force air past the vocal cords, generating physical, mechanical vibration that resonates through your own tissue. This anatomical model highlights the vagus nerve. Running from the brainstem to the internal organs, it serves as the body's primary biological brake system for stress. The vibrations from your vocal cords provide the mechanical stimulation needed to engage this nerve, sending a recovery signal down the pathway. As the signal reaches the heart, the pumping rhythm slows. This shifts the body from a state of high alert into a recovery phase. This is a purely mechanical reaction. Because the body is responding to vibration rather than melody, the biological benefit remains the same regardless of your musical talent. This active vocalization provides a biological cue to end the stress response, an outcome that passive sitting or silence cannot replicate on their own. These benefits aren't limited to singing rooms. Even in a quiet academic setting, like Dongso University, smaller vocal actions activate a secondary chemical pathway. When you perform a low-vibration action, such as humming, your body produces a molecule called nitric oxide. As this molecule moves through your airways, it expands the blood vessels and opens the respiratory system, allowing for more efficient oxygen circulation throughout the body. By providing a private space for vocalization, the 𝗨𝗏𝗡 effectively institutionalized a practice that triggers both a neurological slowdown and a chemical recovery system. Students often need stress relief in environments where singing or humming is impossible, such as a library or a shared study hall. This schematic shows the process of airflow resistance. When we whisper, we constrict the vocal cords to restrict air, which physically forces a much longer and slower exhalation. This restriction acts as a bypass for the nervous system. By lengthening the outward breath, whispering calms the body through mechanical breath control rather than vibration. These varied vocal pathways, from loud singing to quiet whispering, provide specific ways to regulate your biology across different social settings. However, there is a clear structural limit. The vocal cords are composed of living tissue, and they are susceptible to physical fatigue. If your voice is already exhausted or strained, forcing sound through that tissue can cause inflammation and structural damage rather than relief. When the vocal system is overtaxed, the only viable mechanism for recovery is absolute silence. Your voice is an internal resource, where the physical act of participation matters more than artistic ability.
Does this change how you view the cultural role of singing in Korea?
And the next time you feel overwhelmed, will you choose active vocalization over passive listening?